Hi children, in today's class we shall try to learn something regarding factors affecting pressure. What are the factors that will affect the pressure of a given thing? Okay, we shall see now. The first thing is factors will affect the pressure in different cases. See now, same amount of forces are applied on different areas. If you apply same amount of force on different areas, if area is more, the applied pressure is, if you apply force, so suppose I already told you in the previous slide, so this is the small area and this is larger area. If you apply same amount of force on those two things, so the smaller area will feel much pressure than compared to larger area. The larger area, the lesser is the pressure, and the smaller area will exert more pressure. The example as that of elephant foot and as that of this point heel. Similarly, different amount of forces are applied on same areas. See now, higher the amount of force applied, the more pressure is going to be exerted. The thing is, when a man is swim underwater the person is swimming, feels pressure upon his eardrums. The deeper he goes, there the pressure he feels much. Deeper in the water he goes, the height is going to be more, force is going to be more, he will feel much pressure if the height is more. Okay, so this is the situation, and the next condition is application of variation of pressure by increasing the area. I think we have already discussed it previously. We shall have a recap now. Heavy trucks have 6 to 8 tires instead of conventional 4. A camel has broader feet and hence can walk in the sand more conveniently when compared to horse. Skiers use long flat skis to slide over the snow, and army tanks are made to move over the broad steel track called caterpillar wheels because of their huge weights. And foundations of the high-rise buildings are wide, and nails or broad pins have pointed, sharpened end. Cutting instruments like blade, knife, axe have sharpened edges. Porters, coolies, they will wear turbans on their head to reduce the pressure of that particular weight. School bags will have wider strip. I think each and everything we have discussed. I just make a notes, a gist or notes for you so that you can make a note of it. And the next one is, there is a note. When a force of 1 Newton acts on an area of 1 meter, the force should be 1 meter and the area should be 1 meter, square meter, that is 1 square meter. The pressure acting on that surface is equal to 1 Pascal. If you are asked to write what is 1 Pascal, so then what you have to write? The force of 1 Newton is held on the force of 1 square meter. Okay, 1 meter square. So that is what we call it as. The expression is P is equal to F by A. Pressure is directly proportional to force and inversely proportional to area of cross section. Here the bigger unit of pressure is kilopascal. Kilo means 1000, 1 kilo means 1000 pascal. 1 Newton per meter square is equal to 10 power 5 dyne per 10 to the power of 4 centimeter square, that is 10 dyne per centimeter square. So commonly used 1 atmospheric pressure. Generally they will be asked in the examination in the form of bits. 1 atm is equal to 76 centimeters of mercury, and whose value is equal to 1.01 into 10 to the power of 5 pascals. Okay, that is very important, children. Right, the next concept. There is a numerical problem here. See now, a force of 25 Newton acts on a body of area of cross section 20 centimeter square. See children, you should observe carefully here. The force is in Newton and the unit of area is in centimeter square. If it is in Newton, it should be in meter square, but it is in centimeter square. At that time you should not be hurry. You should read the question carefully, and you have to have changes from one system to another system. The total answer should be in a single system. So that is why it is in SI system and that is in CGS system. You should change it. Calculate the pressure exerted by the body in Pascal. Pascal will be SI unit. So we shall try to change this 20 centimeter square first into SI unit. So that is the area 20 centimeter square is equal to, 100 centimeters is equals to 1 meter. So 1 centimeter is equals to 1 by 100 meters. So 1 by 100 meters. So centimeter square they told. So that's why 1 centimeter square is equals to 1 by 10,000 meter square. So likewise we took this 10,000, 20 by 10,000, that is the area. So which is equals to 25 divided by 20 into 10,000. It will goes to numerator. Finally you are going to get this much of answer. Next problem, children. What is the magnitude of force required in newtons? They are asking in newtons, that is SI unit, to produce a pressure of 27,500 Pascal on an area of 20 centimeter square. See here, area will be is in centimeter square, that is CGS unit. These two are in SI units. So it is better you convert this first into SI unit. That is 20 centimeter square is equal to 20 by 10,000. We already discussed in the previous problem, because 1 centimeter is equal to 1 by 100. 1 centimeter square is equal to 1 by 100 into 1 by 100, that is equal to 1 by 10,000. 200 by 10,000, which will be equal to meter square, and the pressure is 27,500. If you substitute that 27,500 into 200 by 10,000, so you will get 550 Newton. 2 zeros gets cancelled. Here 2 zeros, here 2 zeros gets cancelled. 275 into 2 becomes 550. It is very simple, children. Next one, a force of 75 Newton, it is in SI unit, can be produced a pressure of 1,50,000 Pascal. It is also in SI unit. Calculate the area in centimeter square. The area should be calculated in centimeter square. First of all, you should calculate that area in meter square, then we go for centimeter square. So pressure is equals to, area is equals to F by P. F by P. Area is equals to F by P, which is equals to pressure is 75 by divided by 1,50,000, that is 1,50,000. Likewise, you are go 15 ones are 15 fives are. So likewise, you got the area. Calculate the area in centimeter square. Centimeter square is equal to, is nothing but into 1 by 10,000. Into 10,000. So in order to, so this 4 zeros and this 4 zeros gets cancelled, we remain with 5 centimeter square. Likewise, we can do the problems, children, and go for one more problem. Minimum 1 kilopascal, kilo means 1000, pressure is required to carry out an activity. A machine which can apply 10 power 5 Newton pressure is used for this purpose. What should be the maximum area on which the force is required to apply so that the activity can be carried out? What minimum 1 kilopascal pressure he has to. 1 kilopascal means 1000 Pascal, which is equal to, which is 1000 Newton per meter square. Hence a minimum of 1000 Newton force is required. Since this is 1000 Pascal, we require 1000 Newton force. Pressure is equal to force by area. So 1000 is equals to 10 to the power of 5 divided by, so for 10 power 5 Newton, 10 to the power of 5 divided by A. A will be equal to 10 power 5000, you will get 10 power 2, which is equal to 100 meter square. So the maximum area on which the force is required applied is 100 meter square. Very simple problem. Go for the next problem. 5 Pascal of pressure is required to exert an area of 250 meter square. The area is 250 meter square. Right. The box is placed on that area and the surface of contact is exactly 250 meter square. What should be the mass of the box so that exactly 5 Pascal of pressure can be exerted? So pressure should be how much? 5 Pascal. which is equals to force by area is how much? 250 meters. The force will be 250 into 5, which is equal to 1250 Newton. So what he has given? He has given what he asked to find? He asked to find mass. So force is equals to F is equals to ma, or F is equals to mg, acceleration due to gravity. F here is 1250 is equals to m into g. Let us take, for our convenience, let us take g values as 10 instead of 9.8. So in order to calculate easily, so which will be equal to 1250 by 10, that is 125 kg, since g value is 10 meter per second square. Let us have some keywords here. Already we have discussed that pressure, thrust per unit area is called pressure. What is Pascal? The pressure produced when a force of 1 Newton acts perpendicular to the area, that is area of cross section is 1 meter square or 1 square meter. So then it is called as 1 Pascal. The pressure is said to be 1 Pascal, whose force should be 1 Newton and on the area of cross section 1 square meter. Next thing, the magnitude of the pressure increases with increase in magnitude of force. If you increase the force, pressure increases, because pressure is directly proportional to force. Similarly, magnitude of pressure decreases with increase in area. Since pressure is inversely proportional to area, but if area increases, pressure is going to be decreased. In SI system, the unit of pressure is Pascal. We decrease the pressure by increasing the area of cross section. Okay, it have been repeated and you can check it once. Small force, low pressure, high force, high pressure. If area is small, pressure will be high. If area is large, pressure will be low. Okay, thank you children. We shall meet in the next class. Please don't forget to subscribe, share. Okay, and first of all, you like it. Once you watch the full video, definitely it will be useful for you children. It will be very useful for all the competitive exams. Okay, any of the competitive exam if you write in physics, definitely it will be useful. Okay, thank you children. Bye.